Good evening and welcome to everyone. A special welcome to all the people that are joining us in different time zones. I'm back today with you hosting this webinar after assisting Teboho last week with the third webinar, which was number 3 in our 7-part series on asset management. I must thank Refilwe for doing a great job last week. Also thank SAIEE and SAIEE in advance for the content, platform, and marketing for these events. We've recorded over 333 attendances, and I see we are doing very well with that number to maintain the average today. I am Prince Moyo, working at Eskom as General Manager for Transmission Engineering. And my colleagues and I at Eskom have a special interest on this topic here because we're trying to reorganize ourselves and try and approach best practice. This is the 4th of our 7 weekly webinars lined up every Thursday. We had general asset management in general in the first webinar, sample artifacts in the second one. We shared last week, Teboho and I, SAIEE Technical Bulletin 787. And today, Teboho is going to give us a presentation on the first of the asset planning activities, which is maintenance strategies. Let me add that video recordings for the previous webinars are available on the SAIEE TV YouTube channel. Please register and you will see we don't have too many webinars in there. As you access the channel, you will see the titles very clearly, and you are free to go through the content once again and recommend it and recommend the channel to others who may not have attended. So the 4 aspects of asset planning we spoke about is expansion planning, catering for growth, and then the risk management aspect of maintenance, refurbishment, renewal, or renewal and operations planning. And the presentations on these are lined up over the coming weeks. The final webinar is going to be on very interesting, and I see the presenter has been joining us. He's joined us today again, all the way from Canada. And it's going to be a talk on the optimization of project portfolios in the light of capital rationing. Please submit your questions during the session. I will try and attend to as many of them as possible. And afterwards, we do answer the rest of the questions, and we'll make a plan to make the presentations and the Q&A full list of questions available one way or another. For today, we are talking about maintenance strategies. I'm going to skip my bio. I'm sure you've seen it if you've been attending these webinars. And I've said a little bit about myself. Let me take you to the presenter today, which is Teboho Mokwana. He's a reliability and maintenance senior engineering consultant at Eskom Transmission, and he has over 15 years experience on asset care regimes that includes the development of maintenance engineering processes and standards, asset health formulation, asset performance management, as well as compliance assurance. He has worked at Spornet, Eskom Enterprises, Eskom Distribution, Eskom Technology, and he holds a Bachelor of Technology in Electrical Engineering from the TUT and a Master of Science in Technology Management from University of Pretoria. He's a certificated engineer, a member of EXA SAIEE ACMESA, and he has presented and published at various conferences. So I'm going to give control to Teboho to take us through his package. Looking forward to an interesting talk on maintenance engineering. Over to you, Teboho.
Hello, everyone. Let me also thank you for tuning in. Our talk for this evening is about maintenance strategies within the context of ISO 55001. Most often when we hear the words maintenance, a picture that comes to mind is that of a maintenance team executing maintenance activities, that is fixing whatever that has broken. So for this evening, we are going to flip that view around and actually focus on the back end. The back end being the justification to what maintenance activities should be carried out. So we are going to be doing a bit of maintenance engineering to answer to the maintainer out there. So the maintainer is constantly concerned with the what, the when, and the if. The what refers to what maintenance activities should be done. The when refers to when should those activities be done. And while the if is conditional, meaning if I do activity A and I find condition is X, then I should do E. So E could be repair, replace, or even do nothing. Ladies and gentlemen, welcome. The presentation is set out such that first I'll provide an overview of maintainable assets in Eskom and the broader concept of maintenance management. We will then have a look at the ISO 55001 and look at what it says about the maintenance. We will navigate our way through the various maintenance strategies and identify optimal approaches. On item 4, we will get an opportunity to do a comparison between the contents of an asset management plan as well as a maintenance standard. We will move over to demonstrate the applications of maintenance approaches through practical examples. On item 6, we'll talk a bit about the prospects of maintenance and how we foresee maintenance changing in the near future. And we'll finally wrap up with a summary of takeaway points. As a start, I thought this illustration could actually paint a picture of megastructures found in many physical intensive organizations, and also demonstrate that organizations are greatly reliant on their assets to actually deliver a certain level of service. We are having this talk this evening because we care about these widgets. In fact, when you hear how some of the engineers talk about these assets, you'll actually think that they are talking about people. This picture is from Eskom. It's showing one of many substations on the left. Then on the right, we can see a field crew doing maintenance on an overhead line. The practical examples that I'll be showing you in the presentation are from the T&D side of the Eskom business, meaning the transmission and distribution, because I'm working for T&D business. However, the methods that I'm going to be sharing with you here today, they are not specific to the T&D business. In fact, it's methods that can be taken, dusted, and adopted to any organization that has physical infrastructure. So let's take a step further to comprehend the types of physical assets found within the Eskom T&D space, and also what sorts of quantities are we looking at. And let me also mention that the list is not comprehensive, as there are many more other assets that we have in Eskom T&D. So the substations, as you have seen the illustration in the previous picture, we have almost 3,000 of those across the country. And these substations consist of a variety of assets that are indicated below the substation on the list. The circuit breakers, we are looking at quantities of over 25,000, while isolators, we have well in excess of 45,000. The power transformers, we have 4,719, and these are transformers of greater than 1 MVA. We generally talk quantities when it comes to distribution, because the numbers are quite high in that space. And within the transmission space, there we talk about sizes, because the units tend to be very big there. So moving down the list, we can see that the medium voltage, low voltage transformers, those are our smaller transformers, and generally they are mounted on structures, and we often see them along the street. And for those, we are talking numbers in the range of 300,000. Then when it comes to the network lengths, we have both underground networks and the overhead networks as well. For those ones, we have a combined line length well in excess of 700,000 kilometers. That's a lot of conductors and structures. And the wood poles alone, we are looking at over 5 million numbers of those. Then, in terms of the values, the regulatory asset replacement value in transmission, we are looking at 94 billion. Then in distribution, we are looking at a regulatory replacement value of about 120 billion. And in the generation space, the figures that are being mentioned are in the ranges of 200 billion. I am showing you these magnitudes to give you an appreciation and a view of what we are actually dealing with within the ESCOM space. Maintenance has a cycle, and this picture by Graham provides a good summary of what is involved when it comes to doing maintenance. So on top of this model, we can see that it all starts with the business objectives, which informs what happens in asset management space. Then the asset management policy and the strategy, those gives a direction to the maintenance cycle, while the production plan indicates that there is a strong link between the operations and maintenance. So the effectiveness of this maintenance is actually reliant on accurate master data, as shown at the bottom block, and also the accuracy of other data, that being the information generated throughout the cycle. So understanding risks and opportunities provides a framework of where attention should be devoted to within the maintenance space. And there are various approaches that can be used to actually understand the risks and opportunities. And those can be modeling, simulation, and criticality analysis as well, to identify where your critical assets are. Then once you have done the understanding of risks and opportunities, you move over to establishing your reliability basis. And there is a range in terms of what approaches can come out of there, starting from run to failure up until RCM, and even going beyond RCM, because there are other approaches like predictive maintenance that can come in as a result of establishing the reliability basis. Then once you have established what maintenance needs to be done, then you take a step further to actually look at configuring the maintenance systems in terms of the condition management information that will have to be managed across the process. Then once that is in place, the cycle takes us to the next step, which is looking at the work management. That is where the maintenance planning, the scheduling, and arranging outages actually takes place. And once that has been done, then the focus is now on executing the work, as well as ensuring that there is continuous improvement on the process. So in summary, to summarize what this model is actually telling us. So this model is telling us that the overall maintenance effectiveness is actually a product of accurate asset data, a product of good risk modeling, good reliability basis, good work management, and good defect eliminations. So as you can see, you are actually having these various elements that are being multiplied. And if it happens that at any stage of this product that we are looking for, there is a reduction in terms of contribution, your overall effectiveness is actually going to drop, because if you are multiplying, say, numbers below a 1, the resulting value there will definitely decreases as a result of inefficiencies that you'll be having within the cycle. So for our talk today, as I've indicated, that we are speaking maintenance strategies, so we are not going to be focusing on the other elements. So we are going to be keeping our talk mainly on the first two blocks, which is understanding the risks and opportunities, and focusing more on the establishing the reliability basis, that being the maintenance strategies for the assets. The theory on the maturity of maintenance practices, it's well documented, and the drivers for this progression on maintenance maturity practices, it has mainly been the need to be efficient in terms of doing maintenance, and also a need to actually reduce cost while increasing the availability. So the higher you are on this graph in terms of the dominant maintenance approach that you apply within your organization, the higher or the bigger is the positive impact to the business overall improvement towards achieving its objectives. So if you look at this picture, the oldest approach to maintenance, it is right at the bottom, which is the run-to-failure approach. So with the run-to-failure approach on maintenance interventions, this one means that there is no planned interventions in place to actually prevent asset failures. So this we can say it's actually for firefighting heroes. And with this approach, if it's applied on critical assets, the consequences can be greatly, they can have a great consequence to the organization because they can be costly. As equipment were getting more complex due to industrialization, the need to prevent failures became more and more important. And the calendar-based maintenance, which we often refer to as the time-based maintenance, it became the next big thing when it comes to doing maintenance, because there was this need to actually want to prevent failures. So this approach, I can say it had the right intentions to prevent failures through fixed frequencies. However, it was flawed because not all failure modes have constant probability of failures. So that was the limitation with this method. Then, as the methods were improving, the usage-based approach came along, And actually the usage-based was the start of the condition-based maintenance, because there was some recognition that some assets deterioration is related to how much you are actually using that asset. So it was a point of duty to say, if my duty cycle on this asset is so much, then I am actually taking away so much life from this asset. Then the condition based maintenance. So this one really was an improvement from actually opening assets to fix whatever that has broken, and actually moving over to doing inspections and tests. So these inspections and test techniques, they became more popular to actually drive condition-based maintenance. So with this approach, basically you measure it first, then the measured results will dictate if a further intervention is required or not. Then the latest in terms of maintenance practices is predictive maintenance. So this one is the latest big thing in maintenance approaches. This method is characterized by a need to predict failure, to actually see when will failure happen in future. So there is a great deployment of predictive technologies such as online sensors. There is automated data collection. There is talks of machine learning as well, which are part of this preventative maintenance. So after preventative maintenance, there is actually no universal name that has been given to this future coming big thing. And there's been various talks, and in this model, Dr. Annibal, actually, he decided to call it the cognitive approach to maintenance, while others, they call it the prescriptive maintenance. But in all these different names that are being given to this new big thing, it's actually a high level of intelligence that goes beyond just predicting maintenance, but incorporating processes and people, and issuing instructions that we can just basically follow. So the human interventions is getting more and more reduced in terms of making decisions when we get to the cognitive level of doing maintenance. All right. I thought also I needed to paint a picture in terms of clearly indicating our limitation in terms of our focus area for today here. So maintenance is a very broad concept, and the intention of this picture is to actually show the various building blocks that are involved when it comes to doing the maintenance. And if we look at this picture, right at the bottom, we can actually see the base of this model. This is actually a maintenance landscape. It's all of the elements that you require. Right at the bottom are the base elements, and it all starts with the asset records. So you need to have your asset base. Your information needs to be complete, because if you have missing assets in your asset records, you'll end up with a situation whereby you are actually omitting maintaining other assets. Then the second block, closer to the asset base, is the block that we are focusing on today. So this block covers the maintenance documentation, and our focus in terms of this block is on the maintenance strategies. So if I can just maybe touch on some of these blocks that are involved without actually going through them. So above the base block, once we have all of the elements at the bottom, such as the processes, resources, matrices, we are now going to start with the implementation and actually also training the staff. Then once we have trained them, then we can start with the maintenance planning, scheduling the work, and execution. Then above that, we measure the process end to end to see that it's actually working. And above that, there is the maintenance assurance, which will assist us in terms of doing continuous improvement. And that we do across all of the activities that are involved within maintenance management. Then there is an element of evaluating asset health indices. And right on top, that is where we are doing our continuous improvement. Let's now have a look at what ISO 55000 says about asset management plans, of which maintenance is one of them. The model on the right shows the relation between the various elements of asset management system. Right in the middle of the flow, we can see that asset management plans are derived from the strategic asset management plans. So these asset management plans are what we need to do for assets. It's things that we need to do on assets in order to address the risks and opportunities. So starting with the expansion planning, we do the expansion planning for growth. We see opportunities for growth, then we expand. Then the maintenance planning, we do it for life management. While the refurbishment planning, we do it for renewal, which means if maintenance is no longer effective, we refurbish the plant so that we can get it to be renewed such that it can perform to a level that we are expecting. Then the operational planning, we do it for flexibility, which means if there is a disruption on any part of the network, we look at what alternatives are there. And this speaks to the need for redundancy. So this this model demonstrates that maintenance planning is one of the key elements of asset management plans, as mentioned by ISO 55000. Then organizations can actually take a step further to develop a maintenance policy. So if the asset management policy was not prescriptive enough in terms of what needs to be done within the maintenance space, organizations can actually develop a document that can actually interpret what is in the asset management policy. So this document will give direction to elements within maintenance. The various elements that are shown on the maintenance landscape will actually get the direction from this policy. So this example that you are looking at, it's an example from ESCOM, and it starts with a policy statement to actually indicate the intent. For ESCOM, it says that the maintenance should be aligned to asset policy requirements of ISO 55000 and enable ESCOM to meet its objectives. So that is the high-level intent that this policy seeks to drive. Then the policy objectives relate to what is to be achieved. And in the case of ESCOM, assets should be maintained in such a way to enable the sustainable achievement of the business objectives in a way that we comply with the safety, regulatory, legal compliance as well there, yes. Then within a policy, there are key principles. So the key principles are the things that need to be embedded within the maintenance practices. So whatever that we do, it has to align with the elements that are found within the key principles. So let's look at what is the purpose of maintenance. And actually, the purpose of maintenance has been well defined by John Mowbray, where he's actually linking it to design. And he has stated the definition to say the purpose of maintenance is ensuring that physical assets perform as per the design. So that is the reason why we need to do maintenance. And if we look at the picture, it actually shows you that you have an asset that has been designed to have a particular level of performance, and over time that performance drops as indicated by the red line. So maintenance is going to actually try to pick up that line to a level of design performance. But the issue is with maintenance alone, over time, you find that maintenance interventions are not sufficient to actually give you that designed performance. So to close that gap, you can actually do refurbishment to do a renewal on your assets so that they can perform as per the design. Then, when it comes to maintenance determination strategies, the RCM approach leads in popularity, and it really revolutionized how we look at maintenance. It came up with a multidimensional view that failure mechanisms are different, and the maintenance strategies applied on assets should be aligned to the progression of how failure actually occurs. So if you looked at the previous approaches that I've indicated, starting with the run to failure, up to cognitive way of doing maintenance. So RCM is saying there is no one right way. You actually need to look at the failure and actually look at its impact and customize what needs to be done on that asset. So the reliability maintenance approach, if you look at the history, it originated from the airline industry in the 1960s. And the cost of maintenance was becoming increasingly high due to failures. And the airline industry decided to establish a work group which investigated the effectiveness of the preventative maintenance program that was applied at that time. So the findings by that work group, as they were analyzing all of this failure information that they had at hand, the findings was that no matter how much preventative maintenance they were doing, it was not actually solving their problem because the majority of assets did not have a constant probability of failure. So a process of most effective maintenance strategies was developed, and it was named the RCM approach. So we can see the RCM approach as a most effective maintenance approach, which looks at various maintenance options and actually select the most optimal method that should be applied. The process itself is rigorous because you have to actually scrutinize each and every asset and understand how it can fail and make recommendations that can prevent those failures. So it provides a sound technical and economic justification because there will be times whereby actually doing run to failure maintenance is a good approach because it will have considered the implications, and if doing run to failure is of value for that asset, then that might be the recommendation. The RCM study that was done within the airline industry, it also uncovered that the traditional view on asset failure, which is to say normally assets have a constant probability of failure and they tend to fail with time. It actually proved that that view was actually wrong. And in their analysis, as they were looking at the probability of failure of these various components, they actually came up with these 6 patterns of failure. So these 6 patterns of failure were uncovered as a result of looking at that data. So on the right, it's actually their results in percentages, and it indicates that the pattern F, which is the pattern that had the traditional view of how failure occurs, it actually indicated that the pattern F, I think I'm missing a slide here. Okay. All right. So the findings indicated that 68% of failures, they actually related to pattern F, which is the one right at the bottom, which indicates that the probability of failure is high during the inception, and it becomes not fixed throughout. So meaning it changes, it's no longer high. Then with regard to the bathtub curve type of failures, the findings indicated that 2% of failures they fit the pattern of a bathtub curve. Then the pattern C indicated a percentage there of 5% to indicate that some component failures they actually progress with time. So initially the failure pattern is low, but with time it moves up. So with this slide, the intention is to summarize what is involved in terms of doing RCM, and Praxma has actually summarized this picture to say doing RCM is actually a 3-step approach, and it actually starts with selecting an asset. Then after selecting the asset, you move over to the FMaker. Then once you have done the FMaker, you will do the RCM logic tree, which is a process of actually leading one to the most optimal maintenance recommendation. Then, of course, at the end, you'll document the result. So let's take a view in terms of the steps that are involved. So like I said, the first step is to actually select the asset, and in this case I've given an example of a transformer here to say you'll select an asset, you'll identify what is in scope and also what is outside of scope. For example, your bushings can be in scope, and you will need to look at each of the components that makes up the transformer. Then the next step is to do the FMaker. The FMaker is the failure modes, effects, and criticality analysis. So in this step, we are scrutinizing failure patterns on each of the components that makes an asset. And in the example here is an example of a breaker. And for this breaker, the function of a breaker mechanism is to actually open a breaker. Then the functional failure can be it fails to open the breaker. Then there are various failure modes that can be identified for a breaker. And to take an example, one of those failure modes can be a mechanism one was slow on the breaker. So in terms of the criticality is high, and the failure effect is that the upstream breaker clears the fault, and there could be a loss of supply there as well. So we can see that the RCM is actually a structured approach. Then while we are still on RCM, there is also a decision tree. So I have this picture here to show you that as part of doing the RCM, you will need to run through the decision tree. And this decision tree actually is what will take you to the optimal maintenance activity. So you will ask questions, and those questions will be either a yes or a no. Maybe just to go through one question, you will, for example, ask a question saying, will the loss of function caused by this failure mode on its own become evident to the operating crew under normal circumstances? So if your answer was a no, so that type of a failure, it will be taken as a hidden failure. And RCM will tell us how do we deal with the hidden failures. And an example can be you can do an on-condition task to actually search for those type of failures. Again, while we are still on RCM, so the intention here is to actually link up the various maintenance strategy recommendations with the action required. So for example, on the left of this table, we can see the various maintenance strategies. For example, the run to failure. If you have an approach that is a run to failure recommended by the RCM, so what you need to do is to either repair or replace upon failure. And this is applied for non-critical failures, as I've indicated, and the cost to actually detect or eliminate failures, it actually exceeds the benefits here. Then with the scheduled restoration, on this one, we repair or replace on time. This is more like time-based maintenance, and it will be effective if we have great documentation on the mean time between failure studies. Then the on-condition maintenance, this one is our predictive. It includes the predictive. It's both the condition monitoring as well as the predictive maintenance. So with this element, we employ condition monitoring to detect early stages of failure on assets. And asset failures that normally are recommended that are recommended that we can do on condition maintenance on are normally random failures. So with the on condition maintenance, you can be able to actually identify those type of random failures. Then there is also a recommendation which is the redesign or redundancy. So here is if we see that with the maintenance recommendations that we have recommended, we are not coming right. So a recommendation here can be, let's do a redesign. And normally this will be applied on critical assets that we don't want them to fail. So now that we have looked at the theory on maintenance approaches, let's now bring it closer to how Eskom is approaching it. So in Eskom, currently our maintenance approach is predominantly condition-based activities. However, these condition-based activities, they are triggered by time. And the reason why I'm saying it's condition-based activities, we are doing more of inspections and tests. In the past, we used to do major overhauls, whereby we open equipments and we look at the conditions in there. So now with the current approach is that we do tests and inspections, and the result of those will dictate what we need to do further, if we need to replace a component or we need to fix anything. And what we are currently busy with, we are actually setting up our systems to progress to condition-based, to progress to a full condition-based maintenance. This means we are creating data fields in our computerized maintenance management systems so that those inspections and test results can actually be used to trigger maintenance. So we can be able to apply a level of automated generation of work orders that are based on the deterioration of condition that we see. So for us to get to predictive maintenance, we'll need to apply online sensors as well as computational intelligence on our assets in order to get there. So again, while we are still on the ESCOM approach, I thought I should also just indicate that there are various approaches that one can actually adopt when it comes to doing maintenance. So we call this maintenance strategy determination approaches. So one can make a choice to just follow what the OEM say. So if the OEM say do that inspection and do that test, that can be an approach that one follow. But the limitation with that approach is that the OEMs are normally not involved with the operational life of the asset. So the asset owner is the one that will understand that asset better, because along the life of this asset, we are actually going to be improving what the OEM has recommended. Then there's an approach that is called the PMO, that is called the preventative maintenance optimization. With that approach, you actually look at the existing practices and you improve from what you have. So you simply look at saying, this is how I'm currently doing it, and this is my limitation, and you improve in those lines. Then there is another approach which is called the RCA, being the root cause analysis. With the root cause analysis, you actually look at the failures that has occurred, and you put effort on trying to make sure that those failures don't occur again. Then the FMAker and HAZOP, those two, they are used a lot when it comes to designing to ensure that you proactively identify what needs to be done for maintenance. While the RCM is what we have spoken about. So how we approach it in ESCOM, we do the failure modes, effect and criticality analysis. We do that to actually study the asset potential failures and recommend feasible maintenance approaches. Then we do what you call asset classification, which is looking at the functional importance, the environment, the duty cycle, as well as the asset health. So these are the factors that might influence the asset failure. Then at the bottom, we do optimization, which is simply a grouping of maintenance activities that can be done through the same outage. And of course, we do outage optimization as well. So we have documented processes which defines how we are supposed to be doing maintenance, and those processes for doing maintenance, they actually start in design. So when it comes to how we do it from design, it starts with the stakeholder requirements. So we look at the stakeholder requirements in terms of the levels of reliability that are required, and we apply design methods which we will use to converge to a solution. And the outcome of the design will actually be what we call the design base. And that is simply what we call also the physical, the operating, and the maintenance. So the physical is basically how that asset is configured, the dimensions and how it looks, while the operating base will speak to how we are supposed to be operating that asset. The maintenance element will give direction to the maintenance activities that we'll have to do. So in summary, this picture says maintenance starts from stakeholder requirements, and as part of the design process, we have to make sure that we are designing with maintenance in mind. And now we are moving over to where we are going to be doing a comparison between a maintenance standard and an asset management plan. So this is an example from Eskom, and it shows the contents that are found within a maintenance standard. But let's have a look at this slide, which is basically doing a comparison between a maintenance standard as well as a asset management plan. So to summarize the differences between these two documents. So firstly, the similarity is that these documents are identifying the activities that need to be done on assets. So they both speak to activities that needs to be done for assets or on assets. The differences are that the maintenance standard is focused more on maintenance activities, whereas an asset management plan, it looks at the whole life of an asset, and it addresses all of the various elements that has to be put in place in order to manage this asset effectively. Then this is an example of a maintenance template that we have in Eskom, basically showing that we do an FMICA. It's more similar to an RCM, and we have customized it to add other elements such as job plans and skills groups that will be doing the maintenance. Then this one is an example of our asset classification. As I've indicated, it speaks to functional importance, the duty cycle, the environment, as well as the health status. So from design, there will be maintenance requirements, but those maintenance requirements, we will need to customize them to specific assets, taking into account these factors that will create a variation to the specific maintenance needs of those assets. Then again, this is an example of a maintenance standard showing that we have done an FMICA on one of our assets, and in this case is a substation electrical component, which is earthing. And you can see there that we have addressed the failure modes, the failure causes, and all of these other elements up until we get to the recommended maintenance activity. So this is what we call the maintenance task table. So this is the template that we use to actually capture or actually merge the maintenance recommendations with the asset classification elements that we discussed in the previous slide. So with this table, we are able to say we have so many transformers, and our inspection tasks for those transformers are going to vary because we have made considerations to functional importance, the duty cycle, as well as the health. So this is what we use to get to asset-specific maintenance requirements. Then within our maintenance standards, we also define the asset health, meaning how the asset health is supposed to be done on assets. And our approach is simply doing the asset degradation review. We look at the condition assessment techniques that are applicable, and also we set the criteria for end of life, meaning we take an asset, we look at how this asset ages over time, we look at the testing techniques or inspection techniques that can tell us how far we are in terms of the asset degradation, and then eventually we put together what we call the end of life based on the results that we'll be getting as we are doing inspections and tests. We can say there is so much life left in this asset. Again, this is just an example of what goes into putting an asset health together. So I won't go too much into details on this. There is a webinar that is going to be taking place that is dedicated to giving us more information on asset health. Again, we are working on a tool that we call the Asset Performance Management Tool. And this tool is a tool that is going to take a lot of things that we are currently doing manual, such as the maintenance strategies, the asset health, and actually encompass them into an asset performance management tool. So for this tool, we have actually compiled the requirements, and these are the requirements that we have for this tool. And in the middle of this block, we can see all the activities that goes into an asset performance management tool, such as the maintenance strategy. There we can see there is an element of space. Then the blue blocks on the outside, those are all the other systems that we currently have within the business. And the APM tool is going to be speaking to all of these assets. And I see in terms of time, I am actually falling behind. I think I just need to actually wrap up. I will go to the slide on predictive maintenance. All right. Yeah, I think to wrap up, I actually wanted to wrap up with this slide. This is actually the last. I think is the last slide on this presentation. Basically, on this slide, I wanted to give a view in terms of predictive analytics, in terms of how it goes. To say that there is a process involved if one wants to get to predictive analytics. So that is the level before the cognitive maintenance. And in summary, to to wrap up what we have covered, I can say that we have seen that the maintenance planning is a critical asset management planning activity, and it's one of the 4 elements within the asset management activities. It is clearly expected in the ISO 55000 standards, and we have also seen that there are various approaches in determining maintenance. And ESCOM uses an RCM approach to actually derive what maintenance we have to do. So on that note, thank you, ladies and gentlemen. I am going to be handing over back to the moderator. Thank you.
Thank you very much. I think it's a topic that you are passionate about. I can see you don't have limitations. You could go on and on. I have a few questions. A lot of people have been asking about recording and so on. It's true that you will get a recording. Just follow the SAIEE on the social media accounts and you will get a link to the recording when it is available. And I have a few questions, Tebogo. I will handle just 2 questions and then the rest we will answer and email out. Lester wants to know, how does a condition-based maintenance strategy influence your maintenance budget setting on a year-to-year?
I am going to ask you to please repeat that question because I didn't hear it clearly.
All right, so Lester is asking, how does a condition-based maintenance strategy influence maintenance budget setting on a year-by-year basis?
All right, okay. I think firstly, it's a very good question because with the traditional approach to doing maintenance, which is the time-based maintenance, you tend to know what is going to happen in advance, and the planning become a bit easier because you can actually say next year I'm going to be doing so many activities. So with the condition-based maintenance, there is a limitation when it comes to budgeting if you don't have a history of doing condition-based maintenance. So there is a bit of learning that will have to take place. As you are doing this condition-based maintenance, you will be gaining more knowledge in terms of the interventions that happens over time. So that is the answer to Lester's question there.
Okay, thanks, Lester. And I suppose condition-based maintenance promises reduced failure and so on. And I suppose that with time, if you are doing it properly, you should see a reduction in the required maintenance budget. A question from Tinkulu: when should you invest when your asset has reached its useful life? He's asking, maintenance still relevant when an asset has reached its useful life? When should you invest?
All right. Firstly, when an asset, actually before even an asset can reach its end of life, planning should actually be in place to say when we get to that point, this asset has to be replaced. But if it happens that you are already there, you then have to look at the limitations that you have in terms of resources. So if it happens that you have limited funds, you might need to do some prioritization to say my resources, I'm going to focus them on those other assets. Then this asset that has reached the end of life, I am going to improve on how I am going to be caring for it. You might increase your you might increase the frequency of your interventions to actually manage your risk closer. Thank you.
Okay, and I think the webinar on asset condition assessment is also going to answer this. Do you replace your assets when they reach technical end of life or not? There is an interesting analysis on that very subject in the webinar week after next. My last question, which I'm going to ask here, is from Homozo, and he's asking, remember Homozo is telecoms, electronics. He's asking, how do you apply techniques, these maintenance techniques, where asset maintenance refurbishment are determined by software or firmware? So you've got assets that your assets last 30 years or more, but how do you apply these assets where you're dealing with electronics? How do you apply these techniques?
All right, okay. So yes, I am going to answer that question in broad terms. Firstly, applying it to electronics. So firstly, the failure mechanisms when it comes to electronic type of assets. So the probability of failure there is normally random. Firstly, to say failure can occur at any time. But again, an advantage with the electronic type-rated equipments is that they tend to be built with a level of self-monitoring. As you can recall that in some of our relays, we actually have some level of self-monitoring. But to come back to the question, so if there is a limitation in terms of firmware and other things that relates to that, so in that instance, I think we'll have to say, firstly, this asset has a life that is directly proportional to the supportability that is in place for this asset. So if the life given is that, if the life for support is 30 years, it's 10 years, this asset we should look at replacing it at 10 years. But between that, you need to manage the failures that might arise. Thank you.
Okay, thank you, Teboho. Colleagues, I think the questions are coming thick and fast. People remember to ask at the end, but I'm going to leave it there. I do see questions from Hilja Lenyatso, Michael Govender, Monwabisi, James, Kaya, Aaron, Peter, and so on. And we will answer them in the Excel spreadsheet that will be edited and made available. Otherwise, from my side, I think what remains is to thank Teboho for his preparation and his delivery today, and just to say that we will get a recording of this for some of the people that had audio problems at the beginning. I think some devices don't automatically accept audio. You will get these on the SAIEE TV panel. Let me ask you then finally to join us for our fifth webinar in the series next Thursday at the same time, which continues with the asset strategies that are asset planning strategies that are applied. We're going to be tackling two on the same day. One is on expansion planning, planning for growth, and the other one is on operations planning. So if you want to know how Eskom via grid planning accommodates all new generation capacity or independent power producers or renewables, and if you want to know how we prevent limitation of transport of electricity to remote sites, how do we keep ahead of the game? And maybe more interesting, if you want to know why you get load shared, you can tune in next week to listen to Leslie Naidu and Martin Kopa of Eskom as they give us that aspect of asset management. Otherwise, let me just encourage you to join our social media handles. SAIEE and SIGRE are both announcing the links to the next webinars and also announcing when the recordings are available. So do follow these two sets of handles and you will be kept abreast. Thank you very much, colleagues, for your time and your patience, and good night.